Thank you very much, Ilma, for the moderation, and also thank you to AET, which is all the time supporting us, and I have been several times here to do some presentations. It is very interesting, and it's a very good stand here, and I'm very proud to also present some sort of an Austrian contribution to the international society. So my talk is about 3D measurement in the so-called Erdstall facilities. The first question, what is an Erdstall? I asked the same question also last year at the conference in San Francisco. Nobody checked it, because Erdstall is a very old name, which means it's a Stelle in der Erde. So this is a German expression. It's a place underground, and it's a very old expression, but it is very used in the science of archaeology. So in this case, this is an Erdstall, which is a man-made digged cave underground. As you can see here, it consists of 7 chambers, so 1 to 7, and the lowest part is about 6 meters below the ground. And all of the chambers are connected with a certain slips. So this is a small space, maybe 40 centimeters in diameter, and one has to climb to the slips either vertically or horizontally or vertically to get into the space. So in this type, this is a very special one. It's in Upper Austria. It has several features. It's a so-called Type B feature of an Erdstall. We know all the other places which are for vineyards to store the wine, or there are other facilities just to get from one place to the other place. But this is a Type B Erdstall. It is good to hide people. And it was erected and used 1100 to 1400 Anno Domini, means it is 800 years in age. It consists of several chambers. The total length from the beginning to the end is 37 meters, and the height deviation is 6 meters. There are building shafts, which is a construction shaft. I will tell you something about this later on. And there are niches of lamps to have some illumination, and there are benches. So this is the total construction of the Erdstall, and now I would like to introduce the metrology problematic of this Erdstall. You can measure this Erdstall in old ways, which is, you know, the several spots, number 14, number 15, you can measure it with the caliper about the distance and also the direction, so you can have some idea about the size of the Erdstall. But we want to have a total 3D geometry of all of the points of all of the Erdstall, and this can be achieved either by LiDAR sensors, so you can apply, and we also applied LiDAR sensors within the Erdstall. The first was a Leica sensor, BLK 360, or the other was a Matterport Pro 3D sensor. And with these sensors, you can accurately measure the 3D geometry from a single point. So the advantages of these sensors, these are long-range sensor from 0.5 meters, maybe to 100 meters, and it is very accurate and reliable. And within this image, if you have a look to the image, you see the result of such a LiDAR image. So you see, so this is the cave underground, and you also have some structure overground. So there are the cars, there are the trees, but I have to tell you, the clouds are not true. So the clouds are man-made driven to the, but the other points are all single ones from the LiDAR sensors. What are the disadvantages of LiDAR sensors in this case? It takes some time. You have to place the LiDAR sensor and hide to another place, because it takes 1 to 2 minutes from the sensor that all of the sensor is capturing all of the area. And the disadvantage is also some sort of the long range, because in the cave you sometimes have places with very close distances which are closer to 0.5 meters. And thirdly, it does not get into niches. And so these are some disadvantages. What we applied here is, this is our sensor. It consists in general of a tablet. This is the center part of it, and some illumination, but it's a handheld device. So with this handheld device, we have then been able to measure all of this. How does it operate? So you can see the operation in general. It has a front end which does the odometry. It is 10 times a second. We get 3D information of one single place, because within the sensor we not only have the camera, RGB camera, but also a depth camera, and for every single pixel we get the depth information and the color information. So this is done 10 times a second. After this, we get this image, this odometry data to the backend, which then operates once a second, and it takes the keyframes from one frame to the other one and combines different frames, and it tries to do a loop closure detection to get from one image to the other, because by the scanning you move the camera and you have several different images, and by this you also have some estimation of the camera position online, which is done back end once a second. After this, then you get the 3D map generation, and with this you can have the map visualization on the screen itself. So this is the general operation. In detail, you can see here the scanning device. So my colleague Raimund Edlinger is scanning this structure. You see it's not very high, maybe 1.5 2 meters high, but he has to go to the wall to scan all the niches, and in this case we also have some marker to have a secure element, considering of one measurement to the other measurement. But in general it was not necessary done all the time. So this is the scanning device. To be more precise, at first we took a Lenovo Fab Pro, which has been constructed 2017, but Lenovo cancelled the production. Nowadays we took an iPhone 15 Pro Max, which concludes of a depth sensor, of a camera, and also of a gyroscope, and by this we have been able then to follow this RT map algorithm, which is the real-time appearance-based mapping, which is a product also of the Google project. So it also has been part of the project Tango, which has been implemented also 2017. Additionally, we had to apply some diffuse illumination in front of it. So this is then the result. On the left side you see the results of the mono camera, and on the right side you see some result of the LiDAR sensor. So these are then measured 3D point clouds and meshes of the structures inside the cave. So you will find out there are some difference. Here at the iPhone we have a lot more structural elements as we get in the LiDAR sensor. So this is some of an advantage also from the iPhone, that we get a little bit more details of the structure itself. Finally, we then produce a 3D model of this Erdstall, and this is the 3D model. And the next screen you will see some video, which is a 3D mesh of all of the points of the 7 chambers connected to each other. So we had 7 measurements, and then they have been connected within the slopes. But you have the possibility now to get into the caves and have some imagination what is happening inside the cave. So this is one of our first results. Now I will highlight some other examples of results of our measurement we have been found out. The first one, we have found out that there may be some doors inside the cave, because we have seen the structure of the frame of the door inside the cave. So this leads us then, in combination to archaeologists, to the idea this is some place for a wooden door, and the wooden door has been fixed by the 3 plots, 2 plots on this side, to have a defense meaning. So one who is inside the cave is able to hide from outside comings because they cannot get into it. Secondly, they are pressed with sticks, and they then have to be told, please keep outside, but we can be able to do something with you. Then we have another finding without the measurement, without the metrology, which is in this case the central building shaft. It is very essential for us to find this because we got then the idea how did they dig the caves. At first they digged the building shaft, which is 1 meter in diameter, 6 meters in depth, and from this building shaft the chambers have been built from this side, from this side, from this side, and so on and so on. So it was easy to do all the material out of the building shaft and to put the material away. After this, finally, then the slippages have been digged in the hole, and finally the building shaft has been closed and has been built by material to get this Erdstall to the primary purpose. The primary purpose is to hide people, and if there is no building shaft, you can have the enter here to the Erdstall, but you have to climb 2 other 1 slips to get into the last chamber. So it's just possible for one person at the same time to get into it, and it is easily to defend the hiding people there. Because of the door is at this place, and we have another feature which is a stone which is lying in front of a slip edge. You see the slippage is a diameter of 40 centimeters. So every time you go to the chamber, you have to climb to this slip, either up or down. For me, it's funny. I've been done this several times, but I know of other people who cannot imagine to do this. So you don't have to be claustrophobic, but it is possible to get there. And for this stone, it is available to close the slip and to stand on the stone, so nobody can have the access from downstairs. Secondly, we don't know exactly, but we found out from the measurement there are signs in the wall. Maybe this is a sign of the architect or of the building people, but the aim of the signs is not very clear nowadays. Then, because of the illumination, all of the cave is dark. There are some special niches here where oil lamps have been placed on the wall, and the oil lamps then illuminated all of the scenery. And we also can find this. You can see this is a part of the 3D model. We had a 3D print out of the model, and also on these ones you can find the erection of this niches. Yeah. What are then the next steps of operation? We want to evaluate the accuracy and the reliability of our mobile measurement system with respect to LiDAR sensors. So we know the LiDAR sensors are very accurate, reliable, but we want to know how reliable and accurate is our system. Then we want to develop a MOBIS, which is a mobile Erdstall scanner system, and we want to measure other Erdstalls also. So we know in Europe, from France to Bavaria to Upper Austria, Lower Austria to Czech Republic, there are 300 to 500 Erdstalls, and we want to measure some of them, and after this to do a typology, to have some Erdstalls of the same architecture, and then maybe we find out there are people who are wandering from one Erdstall to the other one to build this. So this project is funded also by the Austrian government, by the Bundesministerium of Kunst, Öffentlichkeitsarbeit und Sport, and also from the Upper Austrian government. It's a project of making it reliable and visible to other people. So every time you climb into the Erdstall, you destroy something of the Erdstall. So we also want to reduce the number of entries, but we want to make it public and have a lot of people decide what is then the meaning of an Erdstall. And therefore we have the 3D model, and on this homepage we will also then have the possibility to show this to the viewer, that they can virtually go into the Erdstall. And if you want to follow me on the YouTube channel, there is one video. I climb from the very beginning to the last chamber and going back again. It's very impressive, and I want to support some feeling of being there without having you also to be there. So this is one of the main ideas from us to deliver the sense and some feeling of this Erdstall. So there are a lot of different aspects archaeologically to support the science of archaeology, but also for the public to get the knowledge about this. So this is my presentation. Thank you for the audience. I would be happy to answer if there is any question.